In this lesson, I'll start with the basics of analysis: models, algebra, and mathematical functions. And you might ask, why all the math? And the reason is simple, actually. Decision making is at the core of supply chain management. And some of the decisions you'll learn how to make during this course is, how many facilities should I open and where should I open them? What transportation mode should I use? Should I send it by truck, by air, by rail? How should I trade off service versus cost? Where should I source my raw materials from? How should I share risk with my customers and suppliers? How much inventory should I have? How frequently should I replenish it? What is my demand for next year? How can I make my supply chain more resilient, less susceptible to disruptions? These are all the kind of questions that you'll learn how to answer during the sequence of these courses. And these are the kind of decisions you'll be making every day. And at the heart of all of these decisions are analytical models. They are used to make all of these decisions. Now, there is a personal or a people side of supply chain management as well, the softer side, and we'll address that in later courses. But for this course, we're focused in on the heavy-duty analytical decision making. So let's get started, because at the core of it, there are models. So we can classify these models. So a good way to think about it is think about the real world. None of your models will capture the real world exactly. They will all capture pieces of it. So you think on the other side of the wall, we have these different types of models: an operational exercise, a game, a simulation, or an analytical model. Now these first two are things you might have done if you're in play a sport. Operational exercise would be something like a practice game. It's a dress rehearsal for theater. It's where you're going through the motions, but it's not the real game yet. It's not the real thing. In the military, you'll do these a lot. Gaming is where you turn your situation into a game, where you're responding to the human is responding to the interactions of the game. And so you're trying to replicate the real world as much as possible. The other two are where the human really isn't there, where the math is kind of simulating or being used to capture the essence of the reality of the real world you're trying to make a decision on. So you can think of these as I move left to right. They become faster to solve and cheaper, but you lose some realism. It becomes more abstract. We will focus a lot on these analytical models because they're a good place to start, because they're fast, right? And they're cheap. Now, going operational exercises, those are very expensive and take a lot of time. So we will use these, and in this course, we'll mainly focus on these first two on the far right end. But later on in the sequence of courses, we'll move towards the other side. They all play a role. Now, even if you look at analytical models, those have different classifications. And we can think of two dimensions that we can think about classifying them, whether they are evaluation or generation strategies, and whether they're dealing with certainty or uncertainty. So what do I mean by evaluation and generation? Different models will give you different results. Certain models will give you a generation. They'll make a recommendation for you, and we'll cover a lot of these. In certainty versus uncertainty, it's just, am I dealing with randomness, or is everything deterministic or known? So in certainty for strategy generation, we'll be using a lot of these models. We'll introduce you to linear programming, network models, integer programming models, mixed integer linear programming models, nonlinear programming as well. We'll spend a lot of time there because supply chain tools really rely on those models. We'll also look at some evaluation techniques when you have certainty, and that'll really be econometric models. We'll do a lot of this, especially in forecasting, which is interesting. We'll use econometric models like regression here. We'll do a lot with uncertainty for generating a strategy, and we'll spend a lot of time in later courses on inventory theory. For uncertainty, for evaluation, we'll use a lot of simulation, mainly Monte Carlo simulation. We'll explain that later, some econometric models, and in later courses, queuing theory. So supply chain will use a smattering of all of these different types. They all serve a role. One last way of categorizing. I know you're getting sick of this, but it's helpful to think about them. Models can be one of three types. They can be descriptive, where they describe what has happened. They can be predictive, to describe what could happen. Or they can be prescriptive, and they describe what should we do. We'll use all three of these, and the different techniques, you saw some of these in the previous slides, map to these as well. And it's really a function of, what am I trying to do? Am I trying to describe what has happened? And maybe I want to use queuing theory or some simulation. Do I want to predict what would happen? And we'll do a lot of this in later courses, looking at forecasting, because you might use regression or time series or other types of analysis. And then finally, prescriptive. What should we do? And these are models that give you suggestions or recommendations. They tell you what is best, depending on how you define that. So they all serve a role. And you'll hear this a lot, whether it's a descriptive, a predictive, or prescriptive model. Just know how these techniques match. The reason why I bring this up, something like simulation will never tell you what you should do. So when someone says, we'll simulate it to get an answer, all that a simulation can do is say, how well is my current situation, is my current solution. It will never recommend a new solution. So know how the techniques map to what you're trying to get done. So we've divided the course into two. We'll start off on the deterministic side. So this means we'll deal with the known, and we're going to mainly focus on prescriptive modeling. What does this mean? We'll come up with a solution or a recommendation, and we'll do this using optimization. We'll start with basics, which is calculus. Don't get scared. It's just unconstrained optimization, and we'll move into math programming. I guarantee you that every supply chain professional touches a program that does optimization every day. So we want to make sure we know what's under the hood. The second part of the course, stochastic and uncertainty, is where we're going to deal with predictive and descriptive calculations. And so for this analysis, we're going to go basic probability and distribution, statistical analysis, some modeling using regression, and some simulation. So again, this is where we do predictive and descriptive type things. All right, last word on this before we get into the real heart of the course. Our approach to modeling here is not to make you an expert at the math. We want to make sure that you know enough to be able to use it. So you can think of the models as being different types of cars. Some are classics, some are more utilitarian, some are exotic. And right, all of them serve a purpose. We want you to understand enough to be able to drive them. We want you to be a driver. We are not training you to be a mechanic. What do I mean? You need to know enough about the model to make sure you know what the inputs need to be, what the output should be, what are my expectations of what it can and can't do. We don't expect you, and we will not teach you in this class how to fine-tune or understand the core fundamentals of these different models. We will not go into mathematical proofs, for example, of a lot of the optimization and other techniques. We want to make sure you understand how to use it, how to apply it. All right, so this is kind of a quick summary of our approach to modeling, and now we get ready to start with the rest of the course.